Guys, I was asked to do a somewhat complicated problem in chapter 10, the chapter about data mining, and specifically example number 4, which has to do with the association rule mining, it's called, which basically uh, talks about how one characteristic in a data set might have an impact or be associated with another characteristic. And if that's the case, and if you knew that, you could then, as the book says in its text, plan things accordingly. For example, keep them together on shelves, or for marketing purposes, keep them together. If you buy one, you will give you a discount on the other, etc. So the question is, does the data support an association, which they call a rule? So instead of doing the example directly, I'm going to use the book's show me an example in order to have the formulas in front of us while we do the problem. So let's share my screen, and here, let's take here. So this is the example that the book is going to help us demonstrate. So we have two rules. If you have a fastest engine and you're interested in traction control. And the second rule is more complicated because there are two pieces before the then. Now the thing before the then is called the antecedent, the thing that comes first. And the other one is called after the then is called the consequent. So antecedent, consequent. That's the general terminology. In this case, the rule 1, the antecedent is fastest engine. The consequent is traction control. We're going to put the data into Excel, which is not visible here, but if you move it over, you'll see it. Open in Excel. And again, rule 1. Rule 1, so we can get rid of this. We don't need this data anymore. Rule 1, target fastest engine, traction control. So let's see where that is. I think. Why did I lose? Why did I lose? There we go. Okay, we have this problem. We want to know, we want to calculate 3 formulas, so 3 measures of how reasonable the association is. One is called the support, one is called the confidence, and one is called the lift. So we have to calculate 3 numbers using Excel. Could do this by hand, actually. It's not that the calculations are not that complicated for each of the rules. So a total of 6 answers, 3 for this and 3 for that. So let's go back to the Excel. Let's go back to the bottom. So the first rule, which is fastest engine and 3-year warranty, fastest engine is column C, 3-year warranty is column E. Let's do it. We want to calculate something called for rule 1. We're going to calculate the support. So the support equals, so let's see what the book tells us to do. So let's continue. We have to identify the antecedent, the fastest engine. Oh, what happened here? I'm looking at the wrong data set of data. I'm sorry. Let's go back out of here. Yeah, let's close it up. Thought I was doing it right. Oh, I know what I was doing wrong. This was the wrong. That didn't work. Looking at this set of data. Let's go to this set of data. Play. Now, this set of data in Excel. And again, in this example, we're looking for fastest engine traction control. Let's go back What's going on here? I keep losing it on the bottom. There we go. I'm going to go to the bottom. 1 support equals, and we're going to create a formula. And the support we have to again recognize the fastest engine traction control. Well, here's fastest engine is column C, traction control is column N. We want to know how many times you get ones in both columns. 1 and a 0 won't help, but here's like a 1. Maybe this one. Yep, this one, column row 48 at least, has 1 in common. So how often is it? Because if they don't come in common, they're not associated. So let's see how often they come in common. So how can you do that? Well, there's a formula. You can multiply the 1 times the 0. You could multiply one number here times the other number here. If it's either of them is a 0, then the sum will be the multiplication. The product will be 0. Either 0 times 0, 1 times 0, 0 times 1. But if they're both 1s, then of course it comes out to a product of 1. And if you sum that up, you're going to get the total number of times that you ended up with a person who wanted both a fastest engine and traction control. So that formula is called sum product, and we have to give it the arrays involved. So it's column C, row 2 through column C, row 51, comma, because there's only 50, there's 50 sets of data, but the first row is just the headings. And the other one is column N to colon N 51, close parenthesis. But we want it, that's equal to 2. That's equal to 8 times we saw that. So there must be 8 rows if we went through it. But we want to change that into a probability. So we have to divide it by how many there were. Well, the count function tells you how many numbers are found in any set of data. We want C2 colon C51. And the answer should be 0.16. If we go back to our example, now let's go to what they're telling us to do. Telling us to basically do that. How many are between column C? They want to know how many are found. What's the probability the supporters are found in both antecedent and the consequent? Namely, how many have fastest engine and traction control? And they're telling you can do that by the sum product formula divided by the count formula, which we just did. And they claim the answer will be 16, which is what we got. Now let's move on to the second variable. The second measure of how good the rule is, or the association is really, is called the confidence. And that's the same as before, but this time we divide it by how likely it is. Okay, well, let me go back up a step. First of all, the deeper interpretation, the deeper explanation, on the common sense level, is found in my YouTube videos about what's called conditional probability. This is an example of conditional probability. This little vertical line here is red. What's the probability that the consequence is going to happen given that this already happened, or given that we know that it happened? So that formula, which again is interpreted, discussed in those YouTube videos, is you calculate the probability of both of those things happening, which we just did, by the way. That's what we just did. And divide it by the antecedent. What's the probability of the antecedent? In this case, it's traction control. Well, what's the probability? Well, how many ones are there divided by 50? Because it's how many rows there are. Well, if you add up all the ones and zeros and divide by 50, you're going to get what's called the average between all those numbers. So they tell you to calculate the P of the antecedent by looking at the average of column C. Remember, that's the antecedent. So again, in English, that means, with practical terms, is we're going to get what's called the probability of the antecedent. I'm spelling it right. Maybe an E in there someplace. Is equal to the average of column C to column C 51, and that comes out to 44, and therefore to support the whatchamacallit, the confidence is equal to equals 0.16 divided by, I mean, you can do it by formula, 0.16 divided by 0.44. Text. See if we put an equal sign in first. This is 0.16 divided by 0.44. And it's equal to 0.3636 or 36. Okay, so let's see if we got the confidence right. So getting back to the show me an example. 16. We had that before. The average is 0.44, so we have that. And the 364, which is what we got. Let's double check that. 364 when you round it to 3 places. Okay. Now let's continue. Now we need to have what's called the lift. The lift is defined as the ratio of the confidence to the expected confidence. Now, expected confidence is the following. Let's assume, for argument's sake, that the consequent and antecedent is not related. So the probability of consequent given antecedent, if they're not related, then the given information is irrelevant because they're not related. So let's just calculate the probability of the consequent. So the expected confidence, the expected confidence is simply the probability of the consequent. In other words, how many ones there were. Well, we know how to do that. We calculated the expected confidence equals, and here we're going to, let's make it a little bit bigger so we don't accept the rows. Is equal to the average of C2 colon C51, which is 0.44. I guess we had that expected confidence. I guess we had that already, 0.44. And the confidence was 0.36. So the lift is equal to equals 0.44 divided by 0.363. Really 3636. Or value of 1.21. Let's see if we get that right. Let's continue. You know the expected confidence is 30. Oh, my mistake. Okay, my mistake. We want the probability of the consequent I'm sorry, the probability we're assuming for the expected confidence that they're not related, in which case we just want the probability of the consequent. So at this point, what I just did over here should have been not the C, but the N. It should have been an N, namely the consequence, the second one in the line. N, that changes this to 0.36. And what we want here is confidence over expected confidence. This is wrong with expected confidence. Confidence over the is point. Oh, it's 0.363 over 0.36. Sorry, I'm sorry, I got this backwards. Anyway, it's 0.363. It's the expected. It's the confidence divided by the expected confidence. And how much more information is contained by the actual relationship compared to the assumption there's no relationship. So the bottom number should have been that expected confidence. That ratio is 1.01. Let's see if that's what they get. Continue. And that's what we're getting, 1.01. Okay, so I'm going to so the answers, the three answers for rule 1 is 16, 0.364, and 1.01. Now at this point we can repeat the same exact process for the second rule, but the additional complication is that for the antecedent it's two things. So when you go to your sum product, you have to basically use three arrays in the, and I'll show it to you. I'm not going to demonstrate it on Excel, but we'll go through it. So we have antecedent, this is combined, conjunction is called, and this is the single consequent. And we do it the same way. We have the antecedent is two arrays, B and H, but because we're dealing with ones and zeros, if you multiply this times this times this, where the 1, 1, 1 works out, you get a 1. If anything is a 0, it's going to be a 0. The count will still be how many rows we have, which could be any one of these things. They pick the first one. And they come up with an answer, support, which is not very strong, obviously. And then we have the antecedent. Again, I'm going to let you go through this on your own, because yes. And so that's my demonstration of homework 10, chapter 10, number 4.